When people think of German aviation innovation, their minds usually jump to the jet fighters of the Second World War. Yet, a generation earlier, during the First World War, Germany achieved a different but equally significant breakthrough: the construction of the world's first operational all-metal aircraft. The man behind the metal was none other than Hugo Junkers himself. Deciding that the future of aerial warfare shouldn't be built out of wood and fabric, he set out to create a series of increasingly complex all-metal planes, culminating with the Junkers D.I. The corrugated metalwork of this new fighter revolutionized structural strength and would become a lasting hallmark of Junkers aircraft to come. To understand the birth of the first all-metal aircraft, we have to look at the man who made it all possible. Hugo Junkers is one of the most influential figures in aviation history. He is remembered not just for building the first all-metal airplane, but for founding a company that would go on to produce many more innovative and iconic designs. Born in Rata in the Rhineland as the third of 8 children, he chose not to follow the family's textile trade. Instead, he pursued a technical career, studying engineering in Berlin, Charlottenburg, Karlsruhe, and Aachen. Graduating in 1888 with a qualification as a Baumeister, Junkers soon made a name for himself in the emerging field of gas engine development. He co-founded a research laboratory that produced several innovative designs and later established Junkers and Company in Dessau. His appointment as professor of thermodynamics at Aachen in 1897, together with his marriage to Therese Benhold, marked the beginning of a life defined by invention and enterprise. By the early 20th century, aviation still relied almost entirely on wood, as it was cheap, light, and easy to process. Junkers, however, was uniquely positioned to challenge this convention. In 1907, while serving as professor at the Technische Hochschule in Aachen, he met a colleague named Hans Reisner, who was at the time experimenting with aerodynamics. This chance encounter hooked Junkers on aviation and inspired him to rethink how planes were built. Junkers' initial efforts focused on solving the aerodynamic shortcomings of existing aircraft. Rather than accepting prevailing conventions, he approached flight as an engineering problem that demanded rigorous scientific analysis. By 1912, his studies had led him to conclude that many contemporary aircraft suffered from poor aerodynamic efficiency. He championed the use of true airfoil shapes, arguing that wings, fuselage, and control surfaces needed carefully calculated curvature to optimize lift while minimizing drag. To test these ideas under controlled conditions, Junkers funded the construction of a wind tunnel at the Frankenberg laboratory. This facility allowed for systematic experimentation, and over the following years, he carried out roughly 4,000 individual tests and produced around 400 scale models. By 1914, Junkers had become convinced that a cantilever monoplane with thick wings built entirely of metal was not only possible, but practical. Ideally, lightweight alloys such as duralumin would have been used, but contemporary manufacturing techniques made the material difficult to handle. Instead, Junkers turned to iron plates, which were easier to process and allowed him to continue development without a delay. His first step was the construction of a 2.8-meter all-metal wing prototype, and on the 2nd of February 1915, he requested funding from the German War Ministry to build a complete aircraft. Though initially rejected, his persistence paid off when a second request was approved in July, allowing him to complete a prototype by December of the same year. Designated Junkers J1, the aircraft was built with iron ribs covered by thin metal sheets, just 0.1 to 0.2 millimeters thick, held in place by electric welding. A second layer of sheet metal was added to reinforce the whole construction, and the whole thing was powered by a 125 horsepower Mercedes T2 engine. After ground testing, the aircraft was transferred to Döberitz, Germany's primary military aviation testing site. There, on 18th of January 1916, it achieved a historic milestone as the first aircraft with a fully metal structure frame to take flight. Even though the J1 had structural flaws, particularly at the wing-to-fuselage joint, the Inspectorate of Flying Troops, ITFLIG, was sufficiently impressed to order 6 additional examples for fighter evaluation. With this order, Junkers had proven that metal was a viable foundation for aircraft construction, positioning his company at the forefront of all-metal aviation. However, as testing progressed and performance limitations became apparent, ITFLIG's initial interest would quickly start to fade. Hugo Junkers soon turned out a second prototype, the J2, designed to overcome the structural weakness of the J1 by revising the wing fuselage connection. The wings were divided into sections, with the main portion attached directly to the fuselage and the others secured by screws, creating a sturdier design. Finished within only a few months, the J2 took to the air for the first time on 11th of June 1916. It initially flew with a 120 horsepower Mercedes D2 engine, which was later replaced by the more powerful 160 horsepower Mercedes D3. Despite its improved construction, the aircraft's performance was disappointing. While speed was adequate, its weight of 1,160 kilograms undermined its prospects as a fighter. 6 machines were constructed for evaluation, but the Eat-Flick remained unconvinced of the type's practical value. Junkers and his team thus concluded that the key to progress lay in reducing the structural weight. Their attention turned to duralumin, a lightweight aluminium alloy already employed in Zeppelin construction but notoriously difficult to form and work with the manufacturing techniques of the time. Determined to master the material, they designed specialized tools and machinery that allowed more precise shaping and assembly, gradually overcoming the technical barriers that had previously limited its use in aircraft. Encouraged by these advances, Hugo Junkers initiated a privately funded project to build a fully operational all-metal monoplane, designated the Junkers J3. The effort, however, proved short-lived. The Eat-Flick declined to support the program financially, choosing instead to prioritize all-metal ground attack biplanes. As a result, only a single incomplete airframe was produced. Although the J3 was never completed, the project was not a failure. The technical knowledge gained from working with duralumin provided crucial experience that Junkers and his team could apply to their subsequent designs. Building on this foundation, Junkers pressed ahead with his all-metal aircraft program, refining his all-metal concepts through a succession of increasingly ambitious prototypes. The J4 served as the basis for the later J1 biplane, on which we already have a video, while the J5 was abandoned before completion. Development then shifted to 2 new designs, the Junkers J7, conceived as a single-seat fighter, and the J8, a 2-seat close support aircraft that would eventually evolve into the J10 and CL1. Wind tunnel testing during this period revealed that the low-wing configuration offered notable advantages, including improved aerodynamic performance and added protection for the pilot during rough landings. Yet the fuselage remained a persistent challenge, as the team struggled to design a structure strong enough to carry equipment, engine, and fuel tanks while remaining light enough to preserve maneuverability. After a considerable effort, they were able to develop a balanced design that met most of the requirements, the J7. The J7 was constructed using steel bars for the internal framework, covered entirely with duralumin sheets, a method adapted from the J4 but without the fabric surfaces. On 17th of September 1917, Feldwebel Arvid Schmidt piloted the aircraft on its maiden flight, reporting that it made a good impression overall, though the novel rotating wingtip ailerons were somewhat overbalanced. Despite its large front-mounted radiator required for the Mercedes D3 160 horsepower engine, the plane reached a respectable speed of 77 miles per hour or 124 kilometers per hour. Subsequent trials also demonstrated its impressive climb performance, with Schmidt reaching 16,400 feet or 5,000 meters in 17 minutes in a stripped-down J7. With added military equipment, the same altitude could be reached within 24 minutes. Later in October 1917, the J7 was retrofitted with conventional ailerons and evaluated by Lieutenant Coulthard Sachsenberg and Theo Osterkamp in mock combat against the Albatros D3. In these trials, the all-metal fighter demonstrated clear superiority, although minor control issues persisted. Even so, both pilots recommended the aircraft for production. On the 20th of October 1917, the Eat-Flick sought to strengthen Germany's fighter development by establishing cooperation between Hugo Junkers and Anthony Fokker, creating Junkers-Fokker's Warka AG. The intention was to combine Junkers' innovative designs with Fokker's greater production capacity, but the partnership quickly soured as both sides competed for control of the J7 project. Work nonetheless continued, allowing for modified ailerons and redesigned nose radiator to be tested before the end of the year. During one flight, Fokker himself suffered a landing accident. Luckily, the aircraft was repaired just in time for inspection by Hauptmann Schwarzenberger of the Fleet, who praised the J-7 and recommended its inclusion in the upcoming first fighter competition. For this purpose, the prototype was fitted with a new Mercedes engine and aerodynamically balanced ailerons. The competition, held from January to February 1918, saw many frontline pilots test the J-7, including the famous Manfred von Richthofen, better known as the Red Baron. His report noted superior climb rate and speed compared to operational fighters, though he also observed the presence of some oscillation in the wings during sharp turns. Despite further minor accidents, including another landing mishap by Mr. Fokker and damage sustained en route to Dessau, the J-7 prototype proved remarkably robust compared to the other wooden aircraft and was repeatedly repaired for continued testing. In March 1918, Lieutenant Krohn conducted final evaluations, praising its rapid acceleration, responsive controls, and maneuverability, noting it matched or exceeded the Albatros D3 and D6 when diving at 155 miles per hour without any vibration in the wings, though control forces became heavy at steep banks. Subsequent modifications to the ailerons resolved earlier handling issues, and the J-7 was briefly employed by a Fliegertruppe in late March before appearing in the second fighter competition in July 1918. Although the aircraft once again demonstrated adequate performance and durability, it failed to secure acceptance or operational service. While refining the J-7, Hugo Junkers also began work on an improved model designated J-9, which was intended to be more suitable for mass production. Two prototypes were built, J-9-1 and J-9-2, the first of which was ready by April 1918. Structurally similar to the J-7, the J-9 incorporated small refinements that made it easier to manufacture. By March, Fleet was negotiating for 6 test aircraft, but Junkers, frustrated by the delay, pressed for immediate production. In May 1918, he succeeded in securing a contract for 100 all-metal planes, including the CL-1 and J-1. With about 20 J-9s now officially accepted into service and designated as D1 fighters. The first prototype, J-9-1, flew on 12th of May 1918 with Lieutenant Krohn at the controls and was entered into the second fighter competition equipped with a Mercedes D3O engine. The second prototype, J-9-2, carried a Benz BZ-3BO V8 engine, but was sidelined due to mechanical issues. Armed with twin Spandau machine guns, the D1 performed respectably in trials, yet many frontline pilots, including Oberleutnant Hermann Göring, dismissed it as a failure, believing biplanes as a future of air combat. A second commission, however, defended the D1's merits, noting its resilience to small caliber fire thanks to its metal construction, though criticizing its poor downward visibility, which made the plane poorly suited for the fast diving attacks now preferred by the German pilots. Despite mixed reviews, Fleet placed another order in August 1918 for 100 Junkers aircraft, including 20 more D1s. By that time, several prototypes and production models were undergoing static machine gun testing and further trial at Adlershof. Early production aircraft revealed issues with fuselage vibration and reduced maneuverability due to them having longer fuselages and larger wings. To salvage the program, Junkers quickly shortened fuselages and reduced wingspans on all of the fighters still in production. Conceived as a single-seat all-metal low-wing fighter, the Junkers D1 represented a dramatic break from the wood and fabric biplanes that dominated the skies in 1918. Its structure consisted of a steel internal framework clad entirely in corrugated sheets of duralumin, an early aluminum alloy whose rippled surface added rigidity and strength without excessive weight. The corrugation also increased resistance to small arms fire and structural fatigue. This distinctive method of construction would later become synonymous with Junkers' designs, most visibly in German bombers of the Second World War. At a time when most air forces still relied on braced biplanes, the D1's cantilever monoplane layout and stressed metal skin were decades ahead of mainstream practice. Although Hugo Junkers himself remained critical of certain aspects of the design, the aircraft proved both durable and serviceable. Its metal airframe was less vulnerable to weather, easier to maintain, and more resistant to damage than traditional wooden structures. Careful use of lightweight alloys kept the total weight to approximately 843 kilograms. The D1 was powered by the BMW 3 water-cooled 6-cylinder inline engine, delivering 185 horsepower. This gave the aircraft a maximum speed of 185 km per hour, a respectable figure for 1918. The engine's placement offered good forward and lateral visibility, as well as reasonable views above and to the rear. Downward visibility, however, was compromised by the broad, low-mounted wings. The wing structure followed principles developed in earlier Junkers prototypes. A central section was fixed directly to the fuselage, while outer panels were attached with connectors, simplifying assembly and repair. 2 fuel tanks were mounted beneath the cockpit, though precise capacity figures remain uncertain. The landing gear was fixed and conventional for its era, with wheels mounted on a solid axle supported by steel struts. Armament consisted of 2 synchronized 7.92mm Spandau machine guns positioned above the engine. Between May and August 1918, the Inspectorate of Flying Troops (Idfleet) ordered 40 aircrafts. Junkers completed approximately 27 before production ended in February 1919. The joint Junkers-Fokker Worker AG was assigned an additional batch of 20 machines but delivered only 13. Total production, including 2 prototypes, amounted to roughly 40 aircraft. There were even discussions of awarding a further contract to Hansa Brandenburg, but the signing of the armistice in November 1918 brought all expansion plans to an abrupt halt. With so few aircraft completed, the D1 reached frontline units only in small numbers and was likely only present in the Flanders sector in October 1918. After the armistice, 5 examples were captured by the Entente in early 1919. 4 at Hombeek in Belgium, with 1 in flying condition, 2 badly damaged and 1 of unknown status, and another near Brussels, missing half its parts. Evidence of combat use remains uncertain, though markings behind the cockpit of 1 aircraft may have been kill tallies, and another showed bullet holes of unknown origin. At the war's conclusion, the US Air Service reported that no witnesses had seen the D1 in flight, though some RAF pilots believed it had been used operationally. After the armistice, several aircraft were deployed to the Baltic region, where German volunteer formations continued fighting against Soviet Bolshevik forces during the chaotic conflicts that followed Germany's withdrawal from the Eastern Front. The D1 saw action with Kampfgeschwader Sachsenberg, a volunteer air unit commanded by Lieutenant Gotthard Sachsenberg. Operating in support of German Freikorps formation, the aircraft were primarily used in a ground attack role rather than as pure air superiority fighters. In this role, the D1's rugged all-metal construction proved advantageous, particularly when operating from improvised airfields under harsh weather conditions. The Junkers D1 ultimately stood as a bold experiment that bridged the gap between traditional wood and fabric fighters and the all-metal aircraft that would dominate aviation in the decades to come. Though produced in limited numbers and never widely adopted during the First World War, its innovative design demonstrated great durability and resilience in combat conditions. While its operational role remained small, the D1 proved that all-metal construction was not only feasible but offered many clear advantages, laying the foundation for future aircraft development. Today, the sole surviving example can be found at the Musée de l'Air et de l'Espace in Paris. If you want to learn more about the Junkers J1, the world's first all-metal aircraft to enter true series production, you're in luck. We've already dedicated a full video to it. And if you enjoy what we do, don't forget to subscribe so you never miss a new upload. You can also check out our ever-growing collection of articles over at plain-encyclopedia.com. Thank you and see you next time.